Thank you for joining us for this episode of the Payne podcast series as part of CCUS Month at Mines. Today we're here with a team from Carbon America, a carbon capture and storage startup located in nearby Arvada, Colorado. Thanks for joining us, everybody. Why don't we start with you all introducing yourself?
I can start. My name is Miles Abarr. I'm the chief engineer over at Carbon America. My training's in mechanical engineering. I actually went to CU and did a PhD program there, and then joined Carbon America, which used to be a different company called Bright Energy Storage.
And I'm Scott Frazier. I'm the CEO, and I'm actually trained as an aerospace engineer, as you'll find all of us are here. I worked in the rocket industry for almost 20 years before kind of coming over to the clean energy space in about 2001.
Thanks, Scott. This is Kevin Pykkonen. I'm the Vice President of Business Development at Carbon America. I've been with the predecessor company or parent company that Miles described for about 10 years now or so. Scott and I go back that far. My training is in aeronautical engineering, undergraduate degree there, and I got a business degree along the way also. I and Charlene spend our time on the commercial side of the business as opposed to the technical side. That's more of Scott and Miles' domain. And I did, when we're talking about storage, we're talking about geology, and right out of engineering school, I did work for 5 years as a wireline logger for Schlumberger. So I still remember something about the subsurface and can keep track when our real experts are talking.
Good morning, and thank you for your time today. I'm Charlene Russell. I'm the Chief Commercial Officer for Carbon America. My focus in the company is leading the team that is developing carbon capture and storage projects. I am a chemical engineer by degree from the University of Kentucky that migrated quickly to business leadership roles. I'm a 30-year veteran of the chemical and oil and gas industries, and I've worked as a leader in the CCS space for 9 years now, developing both project and policy. I started working with Carbon America last fall after I met the team and understood the mission and focus of the company.
Very cool. And such a wide variety of backgrounds. Why don't you tell me a bit about Carbon America?
Sure. This is Kevin. I'll start with that, and other people can chime in. So as Laura mentioned, we're an Arvada-based startup. Although we have a little bit of a long track record going back some 10 years to the parent company. But Carbon America as a formal legal entity was formed about a little bit over a year ago, although the idea has been being developed by Scott and others in the team for a couple of years more than that. Really, with the change in federal policy on 45Q, it made an economic incentive to go do carbon capture sequestration, and we took ideas that we had in hand and started chasing that. We think, unique in the industry in the sense that we are a end-to-end project developer, vertically integrated. We can handle everything from the capture technology to transportation to the subsurface pieces that distinguishes us among other people out there doing project development. And as we'll talk about, we are also a technology developer, and we have a transformational technology that we're working on for carbon capture in coal plants, cement plants, SMR hydrogen factories, and steel plants that we think can make an impact. I would say Carbon America, from its beginning, has been focused on working on ideas that have the potential to make a difference on a global scale for the climate. So Scott mentioned the energy storage was a place to look at enabling more renewables on grids. And clearly, carbon capture is something that's going to be critical to meet all of our humanity's objectives for mitigating or arresting climate change. Our financial backers have been firm on that too, and we've had patient money, if I can say that, that's been with us this long journey. But we are set to grow very quickly now in the carbon capture space and have large ambitions there. And I'll stop there and let other people chime in if there's anything I missed.
Yeah, I was going to add, you started to get into a little bit, this Miles, but the reason we chose carbon capture is because we really believe that this is the solution, or this is not the solution, but this is an excellent solution to help mitigate climate change. Sorry about my dog in the background. Our vision as a company is to make climate change history, and that is our only goal, really. We're not doing it, to prop up fossil or help extend fossil lifetime or anything like that. It's all about what's the lowest cost way to decarbonize. And if you look in the literature, there's a field of it's called like capacity planning or resource planning, but generally they're modeling things like the grid out to 2050 and figuring out how do we decarbonize, what are the lowest cost ways to do that. And I spent, a few years ago, I spent a lot of time diving into that literature. And because I really, before Carbon America, we were an energy storage company, but also a little bit of an incubator, just kind of exploring whatever made sense. And, I really wanted to understand what was the lowest cost way to do this. And I found that anyone who included carbon capture basically helped reduce costs significantly when you compared to when you didn't. And so that's really fundamentally why we're doing it.
Very cool. And actually, this is the first time I've had engineers captive. So maybe we take it back to fundamentals here and just talk about what is carbon capture and storage for the layman among us.
Sure. Thank you, Laura. This is Charlene. That's an excellent question. And I think the fact that the industry has had a lot of engineers in this industry moving this market forward, the fact that we haven't been able to define what carbon capture and storage is very well for the general population is probably one of the things that has kept the industry from catapulting to something bigger already. But carbon capture and storage is a set of technologies that capture CO2 from emission streams that would otherwise be emitted to the atmosphere, and then takes that CO2 and injects it into deep geologic formations where it is securely stored. It's a set of technologies that can help decarbonize hard-to-abate industries such as steel, cement, and power. The capture part of the technology separates the CO2 from an emission stream, generally through a chemical process. And then the concentrated CO2 is compressed to the point where it behaves like a liquid and is injected into deep, secure geologic storage. This is a stringently regulated process overseen by both the EPA and state agencies, as well as many others, that ensures long-term and safe storage of the CO2.
Awesome. Thank you for that. And so I know, Charlene, you came from oil and gas. The others, how did you, I guess we've covered this a bit already, but let's talk a little more about how you came to enter this industry. And I guess you said the 45Q tax credit made it a little helped on the profit side. Is that enough?
Let me jump in and answer. I guess just a little bit of my history. I'm not quite a Colorado native, but I grew up here in high school and left to go to college at MIT. And while at MIT, I did research on structural dynamics of wind turbines as part of my degree program. And this was about the time that the now NREL wind energy test site in between Boulder and Golden was being established. So in the second year, I approached them after my freshman year at MIT and said, "Hey, can I work out there this summer?" And they said, "Sure." So that was my first foray into green tech back when wind was first fashionable before, well, not everybody on this call was born, but you certainly, Laura. In any case, that was my first start there. I hooked up with Scott and the energy storage domain about 10 years ago. I guess in 2008, I decided to change industries from telecommunications, where I had been spending a lot of time after business school, as an industry where technology is important. And a little bit like Scott said about leaving the space business, that didn't really feel like something that I would necessarily be proud about telling grandchildren or something. What'd you do, Grandpa? It's like, well, I helped telecom companies monitor people's communications and get richer. So I decided to head back and change industries back to green and clean. And that's kind of how I got back involved here. 45Q is the motivator, and it really depends on the project, whether it's adequate. Sometimes it is, and sometimes it isn't. And there's a lot that goes into the economics of sources and sinks that inform that question. So enough about my personal journey, and I'll let other folks talk.
We thought maybe you were interested a bit in how Carbon America came to be. So we thought about that we had this parent company. Carbon America was spun out of a company called Storeworks Power that's been doing thermomechanical energy storage for about 12 years. And we actually started in the back of a bakery over by the old Stapleton Airport, kind of a thing. So it smelled a lot better in a garage. And we had this mentality of build, test, fix. Just let's try. You've got these ideas. If they're relatively simple ideas, let's just try them out, see if it fits with what we've got. And so it was originally underwater compressed air energy storage, and it pivoted along the way. And we We're really focused a lot on thermal energy storage systems and a whole lot of interesting variations around that. And maybe how we kind of got to paying attention to carbon capture in there is we had a thermal technology. One of the things we learned in the power industry is if you can't get the capital costs low, you generally can't displace what's out there. There's very low cost power out there. And so we came up with this idea of using a lot of the existing power assets. So in this mentality of it's already out there, how can we go decarbonize it? It's got to be inexpensive. So we were using a lot of the existing assets. We had a variant that was going to help the coal plants be a lot more efficient and cost effective, but we weren't really thrilled with helping the coal plants continue to pour lots of CO2 out into the environment unabated, and said, well, maybe it's got enough leverage that if we put a carbon capture system with it, it'd be good. And so we started looking into that. In that thread, we had come across this idea of cryogenic carbon capture, which is very different than what most everybody else uses, a sorbent system, and it absorbs the CO2. And this technique cools the flue gas down to where it frosts out and it physically separates the CO2. And so as we looked at that and realized we got all this experience in thermophysical systems, how would we do it? And we got excited about it. Aside from, this was before the 45Q thing. So it kind of sat on the shelf as, how do you make a business out of this? And so then when 45Q came along, suddenly it was like, this looks neat. And as Kevin and Charlene have both mentioned, the business is broader than just that technology anymore. But that was how we got intrigued. And that's how we realized when the 45Q came along, there was a business here, and there's other parts of the business needed besides just technology. So that's a bit of the origin story.
Yeah, let me add a little bit to that. So I think it's important to realize that what we're trying to do here is provide the lowest cost clean energy, right? And there's renewables, which are awesome. Let's do as many renewables as we can. We all agree with that. They're low cost, but they're intermittent, right? And so you need to fill in the gaps. Most people in the field know that. And so we've always been looking at the problem as what's the lowest cost way to fill in the gaps, right? And that's energy storage is one, carbon capture came up as another. And I think when people first look at carbon capture, they kind of think, oh, well, that's never going to work. It only costs money and costs energy. There's nothing at the face of it. It's like you have to add it to a power plant, pay out for all that capital, and then you're going to pull a bunch of the energy from it. How is that ever going to be a good solution, right? But you're ignoring the fact that, that there's that power plant that already exists, that there's that sunk capital. It's very cheap to run relative to other options for filling in the gaps like batteries, say. And so when you look at it from the perspective of just what's the lowest cost way, it's actually a great solution. And I think most people don't realize that things are going to cost more once you get beyond a certain threshold of renewable penetration. Things are just going to start costing more. There's no way around that. And so 45Q does incentivize carbon capture and creates that business now. We believe that it would still be economical in just a tax, carbon tax world. There's any world where you're basically penalizing for CO2, it would work there as well. Just want to add that.
Yeah, just pile on to Miles there a little bit. So obviously the externalized costs of fossil generation, everybody's paying for, and the price is getting a lot steeper. So Miles' observation that carbon capture will always be an incremental cost is really true. But, you have to weigh that against, the impacts of climate change and sea level rise and all that kind of stuff. So clearly, in the policy domain, which we'll get to, we're looking for ways, again, the most economic way to do these kinds of abatements and mitigations. And so that really is, I think, the kind of the set of scales you need to weigh the cost of carbon capture on against not doing it is, always going to be really severe there.
Right. And the reason we're so big on lowering costs, right, is not because we're just super capitalist over here or anything like that. It's because that's very much tied to time. Cost is tied to time. And we want to decarbonize as fast as possible. This is a massive challenge we have before us, and lowering costs is going to just help.
Yeah, it's interesting to see how the industry is kind of working around the 800-pound gorilla in the room, which is this just massive, unpriced externality of fossil fuel use. And,
right.
But I'm an economist, and so that's my background, and so that's my soapbox that I thought I was going to stay off of, but I like that you guys brought it up. Definitely true, and 45Q helps, but it's certainly not enough to kind of price in the cost to the social cost
absolutely
of
not.
carbon.
Yeah, it needs to be more than $50 a ton. Absolutely.
Right.
Also, Scott likes to say this all the time, but there's also this aspect. It's less, it's just definitely less economical, more just like the political side of things, I guess. But being able to get the fossil people to play ball in terms of decarbonization could be a powerful thing, we think, as well. So we're offering them that with carbon capture.
So maybe we can talk a little bit about Carbon America's technology and what makes it unique.
Yeah. So as Scott mentioned, our technology is a version of cryogenic carbon capture. We call it FROST-CC. And, it's different than the typical ones you'll see out there. It's actually there's hardly anyone working on this sort of technology. And most of the ones out there are sorbent, so some type of like solid or liquid material that kind of grabs onto the CO2 basically. And then there's also membranes, which are effectively a filter that only allow CO2 to penetrate, and then you can separate it that way. There's several other technologies. I won't get into all of them, but ours is what we do is we need to chill the flue gas, so cool it down well below ambient temperature to the point where CO2 will start to solidify and change phase from gas to solid. And then you could just filter, you physically separate it, right? It actually becomes quite easy to separate at that point. It's also nice that it remains in a pretty pure form when it's in solid form. It doesn't grab onto, like oxygen and other impurities that might affect the sequestration side of things. Some other benefits of cryogenic carbon capture are that we clean out all of the other pollutants, basically, or I shouldn't say all, but almost all of the other pollutants, including sulfur, mercury, chlorine, NOx. These are things that will condense out in liquid and solid form, and we can remove them along the way, which is really neat. And ultimately, cryogenic carbon capture naturally produces a dense, high pressure version of the CO2, which again makes it easy to sequester. If we're going to say put it underground, you need it to be at pressures well above atmosphere, and ours naturally does, or cryogenic carbon capture in general naturally does that. So how is ours unique specifically in the cryogenic space? So, we took a lot of care to try and make the system as simple as it can. Most cryogenic carbon capture, most carbon capture systems in general are actually pretty complex. They got a lot going on. They're hard to operate. They're expensive. And we wanted to do as much as we could to try and design a system that was simple to build, low cost to develop, and just low cost overall. And so we decided to use the flue gas as the refrigerant. So we are just compressing, exchanging heat, and expanding the flue gas. We don't have any other refrigerants. We don't have chemicals, no exotic materials whatsoever. We actually don't even use water in our system. So it's pretty neat in that way. It's basically just a bunch of stainless steel turbines and heat exchangers. We're able to find a way to make that relatively efficient and also extremely low capital costs, which is why we're most excited about it.
Laura, I might just chime in. We're talking about storage for the CO2, and the question is, well, can't you use it for something else? And there are lots of concepts of things you can do with CO2. And use it to make synfuels and all kinds of stuff. But really, at the kind of volumes of CO2 we're talking about, you run out of economic uses relatively quickly. And so your only answer is really to sequester it underground, where it will stay for perhaps millions of years, like the fluids that have already been down there. So that's why storage is critical to this. Sure, you can do other interesting beneficial uses of carbon dioxide, but they can't really consume and permanently dispose of CO2 to prevent it from getting into the atmosphere.
Yeah, I think that makes sense, especially given your mission of doing this as soon as possible. I think you could see other utilization methods developing down the line once there's a bit more of a CO2 kind of economy you would hope to develop. But right now, for sure, simply sequestering it sounds like the quickest way forward here in this space, for sure. Charlene, what aspect of Carbon America's work do you find most exciting?
There's so many, but besides the fact that I'm working with a brilliant, fun team that includes experts in their fields and that were led by real rocket scientists and co-founded by one of the world's leading green investors, is the fact that, as Miles and Kevin already alluded to, we are making climate change history through our unique business model. This carbon capture and storage or CCS industry has been lacking organizations that are fully integrated, that want to not only develop projects, but also to bring in our own capital, build, own, and operate them, as well as ensure that they're qualified for value-added streams like 45Q and LCFS, and then wrap them in tax equity as needed. There are no other organizations out there that we know at this point that have that complete integrated business model. We're solely focused on capturing and sequestering CO2. It's our one and only mission and priority with no distractions. So this creates an environment for the whole team and for myself where I know every day when I come into work, all the energy and time I put into my work is going to make a big impact on climate mitigation.
That's definitely exciting. I love that.
She said it so well, but I think it's the fact that we get this chance to make a difference, and we built this really neat team and great people to work with, and the culture we built. So it's great to come in and work on something you think can make a difference, as Charlene said.
I think it's so important also in this space to make the point that it's not only, people don't need to be working on climate out of the goodness of their hearts. It's profitable and it's good and it's exciting work. So that's great to hear. So we know that there needs to be huge growth in this industry in order to reach the capacity that's going to be needed to stabilize the climate. What do you see as needed in terms of policy or regulation, R&D, or otherwise for this industry to grow and scale as much as we know it needs to?
Yes, there are so many supporting regulations that we can talk about, but I'll focus on a few more impactful areas. And yes, we agree, CCS is extremely important for climate mitigation. A point of reference for that is the International Energy Agency's estimates that 2.8 gigatons of CO2 need to be captured per year to limit global warming to 2 degrees C. Some of the most impactful policy in the past and currently, and probably in the future also, is for CCS is the 45Q and the support from the Department of Energy. The expanded and reformed 45Q tax credit goes a long way in making many projects viable. And the recent 2-year extension to begin construction deadline was critically needed, as well as the final guidance from the IRS. Further enhancements to the 45Q program, such as a direct pay provision, raising the value of the 45Q, an extension of the credit life for a project from 12 to 20 years, as many of these projects are designed to run at least 20 years. And again, by lowering the volume threshold below the 100,000 met ton marker, could bring on additional projects. The historical DOE funding into research and development for carbon technologies and storage programs has been critical in the advancement of the CCS marketplace, and I really appreciate the support of the Department of Energy. But most of the funding in the storage programs itself has been for larger projects that have very long development timelines. If there were a DOE program that could help de-risk smaller, faster projects, then you might get 10 small projects on stream before one of the large ones comes on stream. The same impact, but faster. There are many synergistic policies to 45Q and the DOE programs, but that are being contemplated, but one of the ones that could be most impactful from a state level would be clarifications of pore space rights in sequestration locations.
Our perspective where we're doing our work is very U.S. centric. There are analogs of all of these that need to happen elsewhere. Europe is moving relatively quickly on some of these concepts, but a very different kind of approach, I think, over there. But clearly, to have a global impact, we really need to address what's going on in China and India. And so, that's a great frontier, and policy and things would have to be very different to be fitted to those economies and those governments. But we can't solve the whole problem just here in the U.S., but for us, that's a great place to start. If we can prove our technology here, I think the world is the oyster that we chase next.
Sure. I mean, we know that we're probably not building too many coal plants here in the U.S. as much as they're building them there. And so getting a technology to a point where it's affordable and we can start exporting that is hugely important. So I think you're definitely right about that. And it's interesting to think about the different approach that they're taking in Europe. It seems like a more kind of centralized, as opposed to here, things are much more disparate. But given that we're on the Minds podcast, What should minds and other students know as they think about entering the energy industry, or green tech industry or CO2? Do you have any advice for them?
Yeah, I can take this one. So I think it goes without saying, but it's an extremely exciting time to be entering the energy industry. I think it's pretty much inevitable at this point that there's going to be a massive worldwide transformation of our actually entire economy, not just the energy industry, in order to decarbonize. And the energy industry being maybe the biggest part of that. And so with that, there's pretty much a guarantee for people to have some pretty meaningful, fruitful, exciting careers because of that if they enter the energy industry. And so I also think, though, it's an extremely challenging problem, probably much more challenging than people realize. And with that, I think we need to have innovative thinkers. And so, my advice is something that I try to do, which is to try and be as holistic and quantitative as possible and think through the problem yourself, like really try and understand what are the problems before us in terms of decarbonizing the energy industry, or even more than that. Don't just assume, solar and batteries, right? And wind and batteries or hydrogen, because that's the cool thing this week that don't just assume that those are the right solutions because that's what's, hot in the media. Actually try and have a reason why you think that's the case, and try and be quantitative as possible about it so that, it's not, you're really understanding the root cause. So more direct advice, I would say, is I think it would be smart to focus on the final 20% of decarbonization. It's a classic 80-20 rule. 20% takes 20% effort to get 80% of the results. But then the flip side of that is it's going to take 80% of the effort to get the last 20%. That's where the really hard stuff, the really hard problems are. Things like long duration energy storage, carbon capture, hydrogen. A really cool one I think I'm really excited about is actually carbon capture with bioenergy. So actually it's similar. So you might have, or there's also direct air capture, which is actually taking CO2 from the atmosphere. This is a different way to effectively do the same thing. You actually build some biofuel, you grow some biofuel like switchgrass that sequesters CO2 within the fuel, and then you burn it, and then you use a carbon capture system to grab that CO2 and put it underground. So it's taking it from the atmosphere, put it underground, and that's I think a very exciting long-term solution that can help remove CO2 from the atmosphere. Because as we get to the final 20%, 10%, 5% decarbonization, you're getting to corners of the economy that are just almost impossible. I would say even maybe impossible to fully decarbonize, and you have to pull it from the atmosphere. That's really the only way. So those are just a couple of examples, but I think that's where there's a lot of exciting, hard problems for people to tackle.
Yeah, the prospect of carbon negative energy, whatever the form is exciting. And I think, but yeah, it's definitely hard for some people to imagine, because who could argue with like a carbon negative, say, oil?
Right. Well, it's very expensive, right? But again, the last bit of everything, it's going to be expensive.
Right.
It's not the solution for everything. We need to decarbonize everything else as much as possible. But yeah.
Cool. Well, thank you so much to all of you, Miles, Kevin, Charlene, and Scott from Carbon America, for joining the Payne Institute podcast series. Loved having you. It was a really fun conversation. Thank you so much again.
Yeah, and I think we forgot to say we're hiring, so be on the lookout for job postings.
Thank you. It's a pleasure. Hopefully, it's been informative for all the listeners, and look forward to more from the Payne Institute going forward. Thank you.
Yeah, thank you for the opportunity.
Thanks for having us.
Thanks so much again.